and I made one. So one thing I can do to keep from making fat finger errors is get rid of this fraction from here instead. So if I get a common denominator of 20K, that means that I multiply this by 4 over 4 and this by 1 over 1. So that's 5 over 20K. You're so welcome. Hey, Dio, how are you doing? It's so good to see you. I hope the FYP brought you here. Thanks for my fire, Dio. I appreciate the fire. And that equals 0.5. So VX is going to equal 0.5 times 20K over 5. Okay, I'm liking this VX a lot better because it is not humongous. So I'm going to have 20,000 times 0.5 divided by 5. I'm getting much better numbers. I like these numbers better. I'm now getting that VX is equal to 2,000 volts. It's still huge, but it's not crazy. It's still huge, but it's not crazy. Are you helping me meet my life goals? Have you checked out my TikTok shop? You got this, Dio. Have you been to my TikTok shop to find some books for your babies, Dio? You don't have any babies. What about Pookie and them? What about your play cousins? What about your nieces and nephews? What about the bad children in your neighborhood? Go to my TikTok shop and check out my children's books. So VX is 2,000 volts. So that means that the current down through the 5K resistor is now going to be 2,000 divided by 5,000, which is 0.4 amps. And the current down through the 20K resistor is going to be 2,000 divided by 20,000, which is 0.1 amps. I like that a lot better because 0.4 plus 0.1 does add to 0.5 amps, which was the current for our dependent source. So now that we have numbers that we can live with, I am going to check my circuit analysis. So the way that I do that is I make a law of conservation of energy table and I put all of my values on it. So I'm going to have 5 milliamps. I'm going to have 10 kiloohms. I'm going to have 0.5 amps for that dependent source. And then I'm going to have 5 kiloohms and 20 kiloohms. We are going to find the voltage, the current, and the power for all of these elements to confirm that we're getting the right answer. 10 kiloohms, and the voltage was 50 volts. So I'll have 50 volts here, 50 volts here. I'll have 5 milliamps here, which means that is delivering negative 250 milliwatts. Then if I have 50 volts here, the current here is 5 milliamps. I know that is absorbing 250 milliwatts. So for that left half of the circuit so far, we have that make sure it's right. We have 5 milliamps as the current, 50 volts. That's absorbing and delivering. So that left half of the circuit is absorbing and delivering 250 milliwatts.